All right, so I want to give you some help on this review sheet for this upcoming test. So let's get started. And so for this first problem, we're going to sketch out a right triangle to give us a little picture of what is taking place. So we have this kite, and it is 115 feet in the air. So we'll just say our kite is up here, and that's 115. The length of the string to the kite is 150. So that's describing really the hypotenuse of this right triangle, which is also the longest side. And so obviously we're going to have the ground here, and we're supposed to find the angle that the string, which is the hypotenuse, makes with the ground. Okay, so it's talking about this angle right here. So we're supposed to find out what is x, in other words. So we got to think of the trig function that we would use for this particular angle. So we know we're given the opposite side of this right triangle, and we're also given the hypotenuse. And so we put that together. We know that that's describing sine. Sine is opposite over hypotenuse. So sine for this currently unknown angle will be the opposite side divided by the hypotenuse. And now we solve, and to find an angle, this is when you're going to use inverse trig. So you'll put this in your calculator, secant sine, and then do the fraction 115 divided by 150, and key that in. And that's 50.0554. We're supposed to round to the nearest tenth. That's one decimal place. So to the nearest tenth, that would be 50.1 degrees. And that's our answer for problem number 1. Number 2 is another right triangle trig word problem. So we have this observer that's 120 feet from the base of a tower. All right, so the tower is going to be this vertical leg of the right triangle, and the observer is 120 feet from the base. So the base is at the bottom. So the observer is 120 feet away. The tower is 150 feet tall. Once again, we're just going to make a right triangle. Find the angle of elevation to the top of the tower from the point where the observer is standing. So here's the observer. So it's just talking about this angle, very much like what we were doing before. We're just going to use a different trig function for this problem, because now I'm given the opposite side and the adjacent side. So that's describing tangent. So tangent for some angle we're just calling x is the opposite side divided by the adjacent side. And then once again, anytime you're looking for a missing angle, that's going to require that you use inverse trig functions, in this case inverse tangent. So you're back to your calculator, and you're going to do secant tan, and 150 divided by 120, and to the nearest tenth, it's 51.34019, but to the nearest tenth, we'll say 51.3 degrees. Okay, here's another one. This time we're looking for a missing side. We're still going to use tangent, because for this 79-degree angle, we're looking for the opposite side. We're given the adjacent side. So on this test, just be ready to find either missing sides or angles, whichever the case requires. So this time, tangent 79 is going to be the opposite side divided by the adjacent side. And then to solve for w, I just multiply by 100 on both sides. And now I can go to my calculator and type that in, 110, and then 79 in parentheses. And this is to the nearest tenth. Again, this is going to be in feet. I'm sorry, meters. Just notice that. So it's going to be 514.5 meters right to the nearest tenth. All right. Now we are going to use your unit circle. So make sure you're able to sketch out a unit circle. I'm going to give you a blank one. Not that you're going to have to fill it in for a grade, but you need to, you're just going to be able to mark it up as much as needed to come up with the answers to problems like this. You will not be able to use your calculator for these problems. All right, so let's just, I'll just do a little sketch, but hopefully you've got a unit circle there with you that you can use, and we've done some practicing on how to maneuver around the unit circle. So this first angle, if you think about it as a mixed number, this would be 2 1/3 pi. Okay, so remember halfway around the unit circle is 1 pi, all the way around is 2 pi. So really what I'm looking at here is I'm looking at the angle on your unit circle that is labeled pi over 3 or 60 degrees. And the ordered pair for that angle, the 60 degree or pi over 3, is the x-coordinate where that angle hits the unit circle. It's 1/2 for the x, square root of 3 over 2 for the y. And we already learned that cosine is the x-coordinate, sine is the y-coordinate, and to make tangent, we have to do the division of y over x. Well, this is asking for sine, so we know what angle, we know what ordered pair to use, so it's simple enough. We just look at the y-coordinate of that ordered pair, and that's going to be our answer. So the answer for number 4 is the square root of 3 over 2. Okay, so for number 5, I'll probably just do some little sketches here, but you're looking at your unit circle. If we made negative 60, now you got to remember, you're not going to have negative 60 literally show up on your unit circle. You're going to go down to your unit circle in the place where negative 60 would be, okay, which is right here. So to make this a little easier, I just went ahead and put a unit circle here so we could be looking at the same thing. So instead of looking at my little sketches, what you're doing on your unit circle is you're just going to where negative 60 would be. So you're literally looking at the 300 degree, which is another way of saying 5 pi over 3 in radians. And that's the angle that you're looking at, and it's asking for cosine, and so cosine is the x, and so the x-coordinate there is positive 1/2, and so that would be my answer for number 5. And for number 6, again, just be able to find where 450 degrees would be. Obviously, that's all the way around is 360 plus another 90. So we're actually right here. And so the ordered pair we're looking at is the ordered pair 0, 1. Cosine is the x, sine is y. So my answer for number 6 is 0. All right. For 11 pi over 4, that's 2 3/4 pi as a mixed number. That might help you to come up with where that angle is. So again, that's 2 pi all the way around. And then just, you can see it, 3 pi over 4. It's another way of saying 3/4 pi. That's where I'm going. That's where I'm landing. And sine is the y-coordinate. So I just look at the y-coordinate there for that angle where it hits the unit circle. And so my answer is the square root of 2 over 2. All right, and then we get into some reciprocal functions. So let's see where 1 1/3, this is 1 1/3 pi, where would that be? So this is 1 pi. And then I just need to go another third. So I'm going to land really where the angle is 4 pi over 3. Well, you can see that's 4 pi over 3. So I just go straight to that angle. And you just have to be careful here because tangent is y over x. So that means cotangent is x over y. So I'll make this fraction. It's going to end up being a positive answer because it's negative divided by negative. And it's always true that when you have a complex fraction that each separate fraction has the same denominator, these denominators just cancel each other out. So it starts off as 1 over the square root of 3, but we know we can't leave an answer like that. So this is called rationalizing. And so my final answer is the square root of 3 over 3. All right, and then we got this one. Let's see, this is negative 1 3/4 pi. All right, so once again, negative 1 and then 3/4 pi. So I went halfway around is negative 1 pi, and then I'm going to go another 3/4. So really I land at the angle that's called pi over 4. So I made negative 1 and then another 3/4. So that's the ordered pair that I look at. And cosecant is the reciprocal of sine. So it's like you take sine, which is square root of 2 over 2, and flip it over and then rationalize. So you have 2 root 2 over 2, but these 2's can be canceled. And so we end up with the square root of 2. Okay, so let's take a look at secant 690 degrees. That's our next one. So 690, it's like 360 plus another 330. So really we're just going to land right there at the angle that says 330 degrees. We're looking at that ordered pair. Secant is the reciprocal of cosine. Well, the cosine would be root 3 over 2. So secant would be 2 over root 3. And then we rationalize it. So it's 2 root 3 over 3. All right, and then our last one, unit circle-wise, is tangent negative 240. All right, so negative 180 plus another 60 degrees would land us right there. And we look at that ordered pair. Tangent is y over x. So that's the square root of 3 over 2 over negative 1/2. And again, the 2's would just cancel. And so my answer would be negative square root of 3. Okay, so be ready to, first of all, know your unit circle very well, because obviously if you make a mistake on filling this out, it could affect your answer. So please make sure you're good with filling out the necessary parts, whatever you need to answer the questions on the test. Okay, period is the horizontal length of a pattern. Where does this graph, it has what we call periodicity. Where does it repeat? So if you start here at 0, 0, and you just trace it along, we're back to square one right here, and then it just keeps on doing that same pattern over and over again. So it goes up, it goes down, up and down. And so the horizontal length of one of those patterns is 6 units. So the answer for number 12 is 6. Here, you can start anywhere, but I typically start here at the origin. So this goes up, it comes back down, and then at this point, I'm at the same horizontal starting point, and that same pattern just keeps on repeating. And it took 3 units horizontally to complete one cycle. So my answer for number 13 is 3. All right. Here we have some graphs of sine, cosine, and tangent. So you're supposed to find the amplitude, and so the amplitude is 4 for this graph. The period for sine is always going to be 360 divided by the factor in front of theta, so that's 2. So the period is going to be 180 degrees, and the theta intercepts for sine are always at 0, 1/2 of the period, and then the period. So I'll just write it up there in general. So for this problem, it's going to be 0, 90, and 180. So it just kind of gives us a little preview of some important information. You can always put down these main quadrantal angles on your theta axis. And then this is telling me that actually, instead of just completing one complete sine graph by the time I get to 360, I'm actually going to go through 2 cycles, 2 different sine patterns. So I'm going to be hitting, according to this, at 0, 90, and 180. So I'm just going to make this so that it's 4 groups of 2. Notice the 2, 4 groups of 2. And I'm going to show my amplitude here. So I'm going to be hitting at positive 4 at the top, negative 4 at the bottom. And so here I go. I'm going to reach the top at what this would be 45. Come back through 90, hit the bottom here at 135, and then back up through 180. That's one complete sine pattern, if you will, period. Now I'm going to make another one. So up, down, bottom, and then back up through. I missed 360, but I think you can see it. And so you can see this number in front of theta basically just tells you how many sine patterns you're going to complete by the time, if it's a whole number, it'll be by the time you get to 360, you will complete that many whole number patterns. If it's a fraction, then like 1/2, you will have finished 1/2 of sine by the time you get to 360. All right, so that's the sine graph. So cosine, very similar. The amplitude in this case is 1. The period is 360 divided by whatever's in front of theta, so that's going to be 720. All right, so it's going to take us 720 degrees to finish one complete sine pattern. And then our theta intercepts. For cosine, it's 1/4 of the period and 3/4 of the period. So 1/4 of 720 is 180 degrees, and 3/4 of 720 is 540 degrees. Okay, so I just want you to, in this case, show me a complete, don't just cut it off and only show half. Go ahead and go to whatever the period number is in this case. So you can still do the 90, 180, 270, 360. You're just going to need to add to that to get to 720. So just keep doing by 90, 450, 540, 630, 720. All right. The amplitude is 1. Cosine will hit up here at the y-axis where the amplitude is. And I'm going to be, just keep in mind, these are my theta intercepts, at least at the beginning, and then from there I just follow the pattern. So I'm going to be hitting 180. And then I'm going to bottom out right in between 180 and 540, which is 360. And then come up and hit 540. And by the time I get to 720, that's really one of the sine, what we call the sine, not sine, cosine patterns. So the multiplying by a half in front of theta just makes it longer. It lengthens the pattern. Okay, so there's your answer for 15. And then for number 16, tangent does not have amplitude. The period is different also. It's 180 divided by whatever's in front of theta. So the individual curves are going to be 90 degrees long. And then for asymptotes, we have these vertical asymptotes for tangent, and we find those by doing 180 degrees divided by 2 times whatever the factor in front of theta is. So the first one will be 180 divided by 4, which is 45, and then the others you just multiply by odd numbers. Like this will be like times 1. So just go to the next odd number. 45 times 3 is 135. 45 times 5 is 225, and so forth. And if you wanted to do -1, that would be -45. All right, so let's set this up. Kind of like we did before. These are our main quadrantal angles. But because there's a 2 here, we're just going to do 4 groups of 2. I'm just going to go ahead and do a -90. All right, let's go ahead and set up our asymptotes. We're going to have one at 45. So that means also -45, 135, and 225. And we're going to be crossing. Tangent always crosses right in between the midpoint, in between those asymptotes. Okay, and then again, we don't have amplitude, but you can come up with another point pretty easily if you just put a number in like 22.5 for theta. 2 times 22.5 is 45, and tangent 45 is 1. So that just gives me another point, couple of points, and I'll use those 3 points to sketch out this curve. Just keep repeating those points. All the way across, and that's, you don't really have to keep going. Those 3 will be fine. Okay. Takes care of that, and now we get into some review. Still trying to get better with these log equations, exponential equations. So number 17, I've got 2 logs on the same side, so I got to make those become 1 log, and this is the quotient property. And now I can take advantage of the log property of equality, since there's logs on either side of the equation, so logs just cancel. And so now I'm just solving this equation. And we'll multiply by 3x on both sides, and then divide by 6 on both sides. And so there's the answer for number 17. 18, I got 2 logs on the left side of the equation, so I got to join them together using multiplication. This is the product property. And now I've got to turn this into an exponential equation. So log equations become exponential. So the base of 3 raised to an exponent of 2 equals x squared minus 8x. And it's going to be a quadratic equation. So I'm going to make it equal to 0. I'm going to solve by factoring. And I got 2 solutions, but only one of them is valid because -1 would mean I'm going to be doing the log of a negative number, which isn't possible. So my answer for number 18 is just going to be 9. All right, number 19, same type of deal. 2 logs on the same side go together, since they're being subtracted, I'm going to put them together using division. Log equations need to become exponential equations. The base of the log is 10. The exponent's going to be 1. And I solve for x. I just multiply by 5 on both sides and divide by 3 on both sides. And 50 divided by 3, I believe, is 16.67. But I'm going to check that out. Yep. All right, so number 20, it's single log, so I just need to change it. Log equations need to be changed to exponential form, so I take the base of 4, raise it to the exponent of 3, and solve. So 4 to the third is 64. Add 3 to both sides, and my answer for number 20 is 67. Here's a natural log equation. They also get turned to exponential form. I just have to remember that for natural logs, the base is e. So the exponent for e is going to be 6. And before I go to my calculator, I mean, you could go ahead and use your calculator at this point, but I'm just going to go ahead and make this, raise both sides to the 1/3, and that's going to be e to the second is 2x minus 4. Now you can go to your calculator and do e squared, e to the second power, and then just leave that there, and then your steps will be plus 4, that number plus 4 equals, and then that result divided by 2 equals, and your answer for x rounded to the hundredths place is 5.69. And 22 is an exponential equation, so it's going to be converted to natural log, but I've got to get e isolated first. So 6e to the 2x plus 3 is 15. E to the 2x plus 3 is 15 divided by 6. And now I can turn it to a natural log equation. Natural log 15 over 6 is equal to 2x plus 3. And it's pretty much calculator time now. Just do natural log. Natural log 15 divided by 6. And just leave that decimal there in your calculator. It's 0.91629 and following. And then your steps from there will be subtract 3 from that number. Minus 3 equals. And then divide that result by 2. Divided by 2 equals. So final answer is negative 1.04 rounded to the nearest hundredth. Okay, so that is it. That's this review sheet and the problems on it to help you get ready for this next test. And I hope this helps. If you have any questions, let me know.